motion changes the perception of time. We call it relativity of simultaneity. You're moving, I'm not. You see events as simultaneous. I see them as happening one before the other. But then when you add the distance component in it, now we see very different times. So there could be a third person moving in the other direction, seeing a different time. So how do you define what now is?
That leads to the idea of what is now, and your now and my now are two different
There's
nows.
no now.
There is no now.
No, there is now. There's always now.
There's an
There has
illusion
to
of
be.
now because we're so close together and we're so small. The speed of light makes it feel like we have a now. But now doesn't really exist on larger scales. There's no such thing.
This is Star Talk. Neil deGrasse Tyson here, your personal astrophysicist. I got with me Paul Mercurio. Paul,
What's up, my man? Good to see you.
All
Always
right.
great to
Love
be
you,
back
man.
with you. Love you.
Yeah, you're a comedian and you got a show on Broadway or off Broadway or traveling.
It was off Broadway and then Broadway. Now we're out on the road.
Out on the road, and
it's called Permission to Speak.
a one-man show, and you interact with the audience. and
Yeah,
stuff?
yeah. It's about stories from people, from me. Frank Oz is directing it.
We love Frank Oz.
Created Yoda. Try being directed by Yoda. He's never wrong.
Well, we're gonna do Cosmic Queries today.
Yeah, I love
Yeah.
these. It's a
With an old
grab bag.
old colleague and friend of mine, Hakeem.
Thank you.
Oh,
Thank you.
shit. I'm gonna get your last name. Olache.
So far away.
Way to do your research before the
Hakeem?
show.
Here, let me give you a mnemonic. Think OU shady.
Hakeem Ou Shady.
But instead of you, it's Lou. Olu Shei.
Hakeem Oluseyi.
Yes, sir.
There you go.
Yes,
We
sir.
got
There you
Yes,
go.
yes.
And you were on my podcast. We had a great conversation.
yeah,
Awesome book.
absolutely,
Yeah.
yeah.
I got your bio here. It's great. Astrophysicist, cosmologist. Your previous guest on Star Talk from
That's
a few
right,
years
yeah,
back.
yeah.
And recently, like practically minutes ago, CEO of the Astronomical Society of the Pacific.
Well,
I'm going
look
to ask
at
you about that in a minute.
I didn't know from
and-
your sweatshirt that you were a CEO. You're
Right?
looking good, man.
Yeah, man, we're taking the CEO vibe in another direction, right?
No pretension.
Yeah, we don't need that.
Awesome. Congrats,
Yeah,
man. That's
thank you.
awesome.
Appreciate you,
That's
sir.
awesome, man. Absolutely.
Yeah, thank you.
So you got a podcast, Does It Fly?
Yeah.
By Roddenberry Entertainment, Gene
That's right.
Roddenberry,
Yeah.
Star Trek fame. And you've got a memoir out there.
That's
It's been
right.
out for a
Yeah.
few years now.
Yeah.
A Quantum Life.
It keeps getting released.
My unlikely journey from the street to the stars.
And that's the book that we talked about on my show.
That's right.
It's a
That's
really
right.
That
great
reminds me
series.
of the quote from Oscar Wilde. We are all in the gutter, but some of us are looking to the stars.
Ooh, that's good.
You didn't know about that quote? But you could have put
Oscar
that in the
Wilde.
book.
I could have put that in the book.
Could have been in the book. You could
Could've
call me
been.
next time.
Unless you're drunk on Thunderbird, then you're not looking up at the stars.
And you've also involved with NASA's IMAP satellite.
Yes.
So NASA has no shortage of acronyms.
Right.
So unpack IMAP for me.
The Interstellar Mapping and Acceleration Probe. Can't wait to talk to you about it.
Okay, we'll get there in like a minute.
Yeah.
So the Astronomical Society of the Pacific. I'm a big supporter of theirs, like from way back.
Right,
And they
right,
say it sounds like it's only the Pacific, but
Yeah.
they have a mission statement that's functionally international, getting people to look up.
Yeah. And
That's
not
like
only
I
that-
try to do that every day.
Right, you're succeeding.
Okay.
You're succeeding,
All
right? It's cool now. When
Yeah.
I was a kid, it wasn't so
wasn't.
cool to be a nerd.
Okay.
Right now, nerds are cool. Science,
Yeah.
everybody loves space.
Plus, we were blurs. Okay.
Right, that's true.
Black nerds.
So
There's no way there's a black nerd. No, there's two of them. Trust me.
At least.
They don't know each other yet, but they're there.
Oh, I could give you a list.
Is that right?
Oh, woo.
Do you have a secret meeting before it was like public that you guys were black nerds?
Yeah. It's called National Society of Black Physicists. But
Blurs are a special subspecies of the whole world. Okay.
Because people could ask you, what kind of nerd are you? They come in different ilks, right?
Yeah,
So,
yeah.
What type? Isn't there just one general type of nerd?
No.
Science nerd, but like a TV nerd, like that kind of thing.
Yeah, well, the first question is the difference between a nerd and a geek,
Yeah.
right?
So no, here's the thing. I got this.
you
I
got
this.
it. You got it.
So a geek can be a geek in any specific category. You can be a music geek.
Right.
Okay, where you're just into the music.
Yeah.
But you're not necessarily associated with science if you're a geek.
Right.
You're a geek, you're just into your thing.
Right.
But a nerd, it says something about your personality and your behavior and your
There's like
and
kind of a
things you care
quality
about.
about you.
Yeah,
There's sort of-
the quality of your personality.
Yeah.
I'll give you some examples.
Okay.
I was in the Navy back in the 80s, and a guy asked me, yo, how come you the only brother that don't wear hella gold? And my answer was, it never occurred to me.
And he said, what does occurred mean?
Like, I couldn't even tell the difference. Like dudes loved cars. I couldn't tell two cars apart. Like,
Yeah, what you care about different things.
you care about different things.
Right.
Exactly. Yeah.
So, do you have a vision for the Society of the Pacific?
I do. I do. So the
Where's you gonna take
Pacific has, one
Let me just
thing
remind people, it's an organization that promotes public awareness and understanding of astronomy at all levels.
At all
At the
levels,
amateur
yeah.
level, you get a telescope.
That's right.
You're
Why the
looking
term
up.
Pacific?
Well, that's what began in San Francisco
So the
Bay
first
Area.
president was the director of Lick Observatory, but it's known as America's first and oldest national astronomy organization.
And Lick Observatory is Observatory of Santa Cruz.
Yeah. Yeah. In the Bay Area there, I used to observe supernovae there back in the day when I was a postdoc.
Great place to drink. You know,
No.
you go with a bottle and then boom.
Eat
No.
chips. You got to eat chips at the observatory. So the ASP, one thing that made it different when it was founded was this egalitarian perspective. So they accepted professional astronomers, amateur astronomers, and educators at all the same level.
Because it was all about sort of just lifting
Roll
everybody up.
together.
Yes.
all together.
And
We're
you
on
want to
a
get it out
level.
there.
It's like,
I
the
did
The
not
more you
know that.
include,
That's
the better the knowledge
Yeah.
base.
Highly laudable fact.
Yeah.
high laudable fact.
Because
And
he
then
doesn't
later-
hang out with riffraff.
Just what
He's
you did. Don't make me slap you.
But later,
Like last time.
they added a new group
Yeah.
that is labeled as enthusiasts.
Good.
Yeah. So here's the thing about it. So I discovered them. I went to the Bay Area in '91 for graduate school, and there was this guy at the nearby community college, a name you're gonna recognize, Andy Fracknoy.
Yes.
Who was the CEO.
He was teaching at the community college.
Excuse me. Yeah, he was teaching at Foothills.
Foothills, yeah.
That's right. And so I'm looking at Mercury Magazine. I'm looking at the
Just a sec.
proceedings
So,
of the ASP.
The ASP produces the magazine for the public, Mercury Magazine, and they produce proceedings of scientific conferences.
Of scientific
they got it in everything. In fact,
There
this
is-
probably one of these books is
Exactly.
from that conference. But yeah.
But you know what else they do?
Yeah,
So
right
there
here.
are 90 astronomy journals in the world. PASP is typically between 15 and 20 of the 90 astronomy journals. So they're typically in the top around 17% of astronomy journals. And there you go, a proceedings of those books.
This is for every meeting of
Yeah.
the Astronomical Society of the Pacific, every professional meeting, their proceedings.
Yeah.
And it's beautifully published.
Everybody
and they
has
line them up.
those.
Yeah, we all have these.
Yeah,
And these are just two that are here
Yeah.
relative to others that I have on a different part of the shelf. Galaxy Evolution, the Milky Way Perspective.
Oh,
And so
that's
it's
a
data.
great. Yeah, they made that into a film starring Tom Cruise. He jumps through a Milky Way covered in Vaseline. It's an amazing
And
scene.
equations.
And equations.
So, I mean, there are now hundreds of these. I mean, it's been
Oh,
around a long
absolutely.
time. Yeah.
Oh, absolutely.
So,
So-
very, very good to hear that.
That's right. So I saw them as a scientifically rigorous organization that had the social consciousness to do this educator
Which
training.
nobody else was doing because
No one else
professional
was doing it.
organizations,
It's very
they were
inclusive.
ordained to even talk to the public.
Yeah.
Exactly.
And so,
I-
the
I-
ASP has been everything I care about as a
Yeah,
professional
same.
scientist
Same.
is fulfilled by that mission
Well,
statement.
why
wouldn't be
haven't
here
other
were it
why
not
haven't
for
other
educators,
societies
right?
picked up on that part of it? Why have I mean, you know, it's out there. It's a good example. And be inclusive.
I
bring
have an
the-
answer. He probably has an answer, but I have an answer. In our field,
Yeah.
there aren't many fields where it can reach the enthusiastic amateur and they
Right.
can still participate.
Well, but your show does. Cosmic Queries is a perfect example
What
of
I'm
that.
saying, that's astronomy and astrophysics.
Yeah.
You can't really do, can you do that with physics, really?
Well, you can if you're not pompous like you
no,
are.
No, but it's harder because everybody's looking up.
Yeah.
And, you know, when we discover
It's more
like a
relatable what you
supernova,
say.
a black hole, anything, it's headlines.
Yeah, it's splitting
How
an
many-
atom is less relatable than looking up
How
at the
many
stars.
other sciences make a headline with that frequency? Think about it.
Yeah, that's true. It's
And
relatable.
how many families own their scientific instruments that they use professionally? Like people buy telescopes.
Telescopes.
Right. Yeah.
Yeah.
So
Right.
that's what I'm saying.
Yeah.
Yeah. So good luck with that. Sometimes
Thank
you
you,
need a
thank
little
you.
bit of that, but
Oh, absolutely.
you're at the helm
Yeah.
of a very important organization.
Thank you, sir.
And there it is. So now tell me about the latest NASA acronym.
Yes.
Interstellar Mapping
And acceleration.
and Acceleration Probe.
But you
Yeah.
can't have a thing that says IMAP and then the word mapping is in the middle of it.
Yeah, that's bad.
It's not working. We're going to have to redo this.
The
We're gonna
word,
have to-
the
You can't
word in the
have-
acronym can't be in one of the words of the acronym.
It's like GNU's
Look
not
at this,
Unix.
Mr. Smart Alec over
Remember?
here. And
GNU's not Unix? GNU?
Oh yeah,
GNU?
yeah, right.
Linux? Unix? You guys aren't that old. Okay. Never mind. It's the white hair. So here's the thing. Before this,
He's not nerdy enough.
I was working on a
Exactly.
satellite called the Supernova Acceleration Probe, and now I'm working on the Interstellar Mapping and Acceleration Probe.
Well, no, you're working on Earth. Related to the probe.
Right.
Not working
Did
on
I
the probe.
misuse the word on?
Yes, you did.
Okay.
So
This is awesome.
So why is the word acceleration in the probe?
Because essentially what happens is the sun accelerates particles, right? It creates this bubble. And the example—
the solar wind.
The solar wind,
Yeah. So
right?
the
But it's
heliosphere,
moving
right?
fast. It is supersonic,
Right.
The heliosphere.
Yeah.
But when it hits
Wait. What do you mean supersonic if it's moving through the vacuum of space?
space, is it exactly a vacuum?
Oh, it's approximately a vacuum.
It's approximately a vacuum. Yes,
Okay.
it is. Yes, it is.
Okay,
yes.
so cool. So it's moving
Yeah.
faster than the speed of sound would be in that very reduced vacuum.
Exactly. And what happens is that, so it's almost like a boundary where information only travels one way, which is out.
That's the
But
heliopause, isn't it?
No, the heliopause is what I'm getting to.
Okay.
So just like the example that's given is when you
Stop
run
showing off how much
water.
you know.
I know, right?
Let him catch up with you, and then
Where do you find these two comedians?
I don't know where I get 'em.
These guys know more science than me. I don't know.
I'm done. That's the only thing I know.
You know how
we
you
got to
run water?
lobotomize him first before we put him in.
You know when you run water in a faucet and it makes this, and
Yeah.
then there's that ring?
Yeah.
Right? That's like the heliopause where it goes from supersonic to subsonic.
Right.
So our heliopause is doing that in the interstellar medium. But here's the thing. There was a previous satellite. So the guy who's running is professor out of Princeton named Dave McComas. Okay. So I don't know if you remember the Ulysses satellite
Yes, I do.
that went over the pole.
Went to the sun, didn't it?
Went to the sun.
Yeah.
Went over the poles of the sun. And we got to see that the solar wind around the mid latitudes, you have the regular wind, 400 kilometers per second. Out of the poles, the high speed wind, 800 kilometers per second.
Didn't know that.
So young Dave McComas is the guy who made that famous plot. All right.
Okay.
So then he had an idea, and the idea is crazy. Let's look at neutral atoms coming toward Earth from outer space. Who looks at neutral atoms? We look at photons. We look at different
There's
hydrogen
nothing more
particles.
boring than a neutral atom.
Nothing more
Exactly.
boring.
It's not ionized.
No.
It's not-
It's
yeah.
not.
But here's their origin. These electrons from the sun go out, they hit the heliopause, so there's magnetic fields there. There's ions trapped in those magnetic fields. Those electrons get captured by those ions, and they become neutral.
So it's like neutering a dog.
No. So
Ooh. Okay, well,
anyway, while the ion is ionized, it is tied to the magnetic field and it's stuck out there. But once it becomes neutral, it is no longer stuck. It's no longer tied to the magnetic field
because it has no charge.
because it has no charge. So some of them stream into the inner solar system. So you can get a map of the stuff that is in the
Raining
magnetic
back
field,
down.
raining back down. And they discovered that if you look at the galactic magnetic field, it wraps around our bubble. And perpendicular to that is just like we have a radiation belt around our planet, there is a belt around our heliopause. And so NASA goes, that's interesting. Now let's do a satellite that will look at that in way more detail, study the sun.
As these things go. You
Yeah.
make a tiny discovery.
Yeah.
And
it can open up a whole-
But yeah, opens up. Now you can build an
Yeah.
entire experiment just
That's
for that
right.
discovery.
What do you
That's right.
What do you anticipate that you might find there? Do you have? I mean, you must have some.
And just the unknown. It's the exact same thing. You're going to find something you've never seen before, just like they did with IBEX, right? So now they're looking at acceleration from the sun. They're looking at acceleration in those magnetic fields, and they're testing the interstellar medium and what it's made of, because those particles also stream in. So that's why it's the interstellar mapping and acceleration probe.
So Donald Goldsmith, who's an astronomy writer and co-wrote the original Cosmos, and I actually co-authored a book with him on origins. He has his own LLC company, and because he writes books and writes for TV, it's called Interstellar Medium. No, Interstellar Media. Interstellar Media.
Interstellar, I love
That's
that.
great. It was so
I love-
simple and
so
perfect.
I have an LLC too.
What's
and
that?
Quarkstar.
Okay.
I thought no one would think of that. Turns out there was a lighting company on the West Coast named Quarkstar.
Whoa, whoa, Quarkstar. All right.
Yours is a little bit more heady than theirs, though.
Well, this is a Cosmic Queries.
Yes.
And we can't just shoot the shit forever.
All right, okay, let's do it.
Yes,
All right, this is James H. English. Greetings. He's from Denmark. I read recently that the universe is expanding too fast for our theories and models to fit, increasing the Hubble tension. Do you think the problem is with our models, or is there some physics we just haven't discovered to explain this? I.e., is the rate not constant due to some undiscovered property of space-time?
Or is there something wrong with the data? So
Or is there
are
something wrong with the
models off? Do we trust the data? or do we need new physics?
But if the data's off, the model's off by definition. No,
It's
maybe no.
I spent time at Princeton where they have a lot of theorists. They say never trust an observation unless it's backed up by a theory.
Okay. Well, that's happened. I know of 2 cases where observation was made and it did not fit with the theory. I'll give you a very simple one. It was Art Walker's research. When he first got the images, so when you see the pretty images of the sun with the plasma loops, Art did that first, right? And so the plasma loops had a constant cross-section. And so the solar physicists were like, dude, there's something wrong with your telescopes because we know magnetic fields diverge with altitude. So they should get fatter at the top. They're not getting fatter.
Right, just to be clear, so the magnetic field is confining the plasma.
That's right.
So the shape of the plasma is the shape of the magnetic field.
Exactly.
And so he's saying that the magnetic field is just a constant cross-sectional tube.
That's what
but
the
it should be
data
something
show.
more dynamic than that.
Yeah,
Okay.
at the top, they should get fatter, right? Just like if you
The
look at a
theory said
bar
that.
magnet. Theory said that, right? And Art was like, ain't nothing wrong with my telescopes. So what I'm going to do is I'm going to have the same passband, but I'm going to give you 3 different configuration telescopes. I'm going to give you a Cassegrain, a Herschelian, and a Ritchie-Chrétien. So you can't say it's the optics. And not only that, so we would fly 16 to 22 telescopes with all these passbands, which ended up being a subset of them, the same passbands on SDO and EIT, the solar satellites, and showed, no, this is what nature is doing. It's not an issue with the passbands. It's not an issue with the optics. This is what nature is doing. And now that's what everyone
So
knows.
the theory
That's what
had to be adjusted.
The theory had to be adjusted. Right,
Okay.
right. You had to
Okay,
come
cool.
up with a mechanism.
Yeah, so
to do
it can happen. So
Yeah.
let's get back to Hubble
Hubble
tension.
tension.
Hubble tension, right? So people have
There's been a
looked
lot
at-
of articles,
There's been a lot of articles, right? And so essentially,
and everybody wants to just throw out the Big Bang. That's
throw
clickbait.
out dark energy.
That's
throw out,
clickbait.
That's clickbait.
yeah, right.
Okay.
Exactly. It's clickbait, right?
Yeah.
So essentially, what's been happening is you have the cosmic microwave background radiation, which has been a treasure trove of cosmological information. Then you have the standard way that we measure expansion. I have some object. I know
How fast is moving?
how fast it's moving away, its redshift, and I also know its distance based on its brightness, right?
Right.
And so now I can make a Hubble diagram. I fit the Planck data, I get a value of the Hubble constant. They don't agree.
But the Planck is the cosmic background. Yeah,
right.
The
The
Planck
cosmic
satellite
background.
from
Exactly,
Europe, the
Planck
European
satellite. I be
satellite.
saying stuff, don't you know, I be leaving stuff out, man.
That's why I'm here.
That's why you're here. Thank you. Thank you. Yeah. So
to keep
essentially-
you continuous.
so now there's new James Webb Space Telescope data.
Wait, just set the stage.
Yeah.
So you have data from the early universe.
Yes.
You get a Hubble rate.
You get a Hubble
the
rate.
traditional galaxies, usually with supernova or some other
Exactly.
standard candle.
Yep.
And those two numbers do not match.
They do not
Okay.
match.
In my day, measurements of the expansion rate of the universe differed by a factor of 2. A factor of 2.
Yeah. Yeah.
And so now they differ by just a few percent.
Right.
But
The error bars.
the error bars, the uncertainty, is way smaller than the difference in those two measurements.
Right. Yeah.
So that is a more severe fact than not knowing the expansion rate of the universe by a factor of 2.
So we had a similar problem with the ages of stars and the age of the universe, which depends
remember that
on
one.
the Hubble thing, right? And so it was the cosmological data that had to be adjusted.
Somebody found stars that were older than the
That's
universe.
right. Stars in the halo looked like they were older than the age of the universe, right? But then
And the headlines were, "Oh, catastrophe! Oh my God!
Well, nothing.
Yeah, people like ready to give up on the universe.
Right. But then we realized, oh no, our cosmology needs to be improved. And so, what happened in the 90s, really, post Kobe, that changed everything in cosmology, right? And then
Not Kobe Bryant.
Not Kobe Bryant.
say.
The Kobe satellite.
What you mean right out that game after he got 80, he scored 81 points? That game.
No, not that game. That
So
didn't
the
change.
Cosmic Background Explorer,
Yeah.
one of the first high precision measurements
Yeah.
of the cosmic background.
Mather and Smoot.
So to do it,
Nobel laureates. because
Nobel
of it.
laureates. Yeah.
So circling to the Hubble tension,
So tell me, what's something's got to give?
Yeah, something's got to give. So I think that there's something that we don't understand. I think I'm trusting the measurements, and I think that I trust the theory.
The measurements look good, don't they?
The measurements look good. I was involved in supernova cosmology, right?
Yeah.
And also weak lensing studies for looking at structure of growth and these sort of things. And so all this different data, there's more than one probe, right? People are using different types of stars.
Right. That's where you get
different
the
types of
confidence
candles.
from. It's not just
Exactly.
one data point from one telescope.
So what
Exactly.
James asks is there some physics we just haven't yet discovered?
Are we
And
missing
is that-
physics, or we just have to adjust the model?
Well, people coming up with these models that maybe the expansion rate of the universe, we have it like, okay, there's this initial impulse, right? And then the universe evolves based on the energy densities of the constituents, of which there are three main ones, right? Radiation, which is stuff that moves very fast through space, but almost not at all through time. Matter, which moves very fast through time and almost not at all through space. And space-time, which has its own energy density that we call dark energy, which doesn't move through either one, right? And so initially radiation dominates, then matter comes to dominate, then dark energy, i.e. space-time energy density, comes to dominate.
we think on dark
Well, that's
energy,
what he think, right? In each one, you can look at what the expansion rate would be of the universe. But here's the thing: once we discovered the Higgs particle, first time we discovered what is known as a scalar quantum field. What do I mean by that, right? So
We'll ask you that. What do you mean by that? Don't
So
ask
if you look
yourself
at-
these questions. That's for us to do.
So one of the things that we look
what
at
is a
is
square? What is a scale of
You know
quantum
what?
field?
You and I don't need to be here. Let's go. Let's go
I'll
get a
just
beer.
ask myself questions and answer them. Yeah. Who needs to I'll query myself.
Yeah, you read them. No, no.
But let's just back up. In the United States, we surely would have discovered the Higgs boson.
Oh, yeah.
With our superconducting super collider,
Yep.
whose budget was canceled right around when peace broke out in Europe, between 89 and
Unauthorized
93.
procurements.
Yeah.
there you
And
go.
so the center of mass of particle physics moved to Europe, to
Yep.
CERN, to the Large Hadron Collider.
Yeah, yeah.
They discovered the Higgs boson. Okay, so
Right.
now what happened?
So here's the deal. Here's why I bring this up, because it's what is known as a scalar field. So when you think about the fields that you know of, right? They're like, oh, the electric field, I have a charge, it has an electric field. Magnetic field, I have a charge that's moving, it generates a magnetic field. Gravitational field, oh, there's this matter. So every field you know of, there's some source in matter. But then here come the particle physics. They're like, oh yeah, you know why every electron is identical? Because they don't say it this way, this is mine. You know why every electron is identical? Same reason every C note, musical note is identical, because they're not the real thing. The real thing is the string or the air that's vibrating, right? So they invoke this idea of quantum fields. So the quantum field just permeates all of space-time and is just there.
But nothing is real in that quantum field. In
well,
their, in their-
excitations of the field are our particles, right? So they're the permanent ones and they're the virtual ones, right?
So we measure the excitations as particles.
As particles,
Yes.
right? Now here's what happens though. They say, oh, there's this thing called the Higgs field. It's just there. It's just everywhere in space at all times. It's just there, right? Scalar field, no source. And I'm like, in my mind, as a young scientist, I'm like, is that real? Then they discover, they ring that damn field and create the particle. I'm like, wow. So now what can you do? Oh, inflation. Looks like Alan Guth creates inflation. Looks like the universe rapidly expanded. Oh, I know what I'll do. I'll create another scalar field. I call it the inflaton field. So now you see some dynamics happening. You can just create a new field. So
But it sounds like you're pulling stuff out of your ass
it does. It does. But you're supposed to like use it to make predictions. So you know
to test whether what came out
but
of your
you're
ass is
using
real.
one as a jumping.
that's right.
It's
Right. And
shit is testable.
I actually have a device that does that. I'll bring it to the next show.
Oh, man. You remember the shit list from the 90s?
No.
Oh, it was like a joke. And it lived on the internet, the early internet, and it was like all these different types of shit. One of them was ghost shit. You felt it came out, you wiped, there's nothing on the toilet paper, there's nothing in the toilet, but you know what happened.
Oh, wow. Okay. Okay.
So some people are doing that. They're saying maybe the universe's expansion rate hasn't just been what we think it of, as simple as we think it is.
Right.
And it could, and then another
There'd
question
be yet
is,
another phenomenon acting on the expansion rate
Exactly.
beyond the three that we have
Exactly.
characterized.
What do we
Exactly.
have an idea what it might be? Is
some
there any-
weird quantum
You
field.
come up with something.
Is,
Yeah, you come
is,
up with something.
Is
Yeah.
weird the scientific term you're going with here?
Sure. So, but
yeah.
let me clarify here. So this notion that the expansion rate is misbehaving, let me
Right.
characterize it
Yeah.
that way.
Yeah.
That just means it doesn't match what our three most potent models would give us for it.
Right.
Okay,
Yeah.
so do we introduce a fourth accounting,
Yeah.
or do we say that one of these are wrong?
Right.
Or
Or
maybe
they're all
e-
working in harmony?
Or each of those have to be adjusted. in
There's
some
an
way.
assumption within there as well that comes from the cosmological principle that the universe is isotropic and homogeneous.
Mm-hmm.
And now people are looking. If I look in that direction, I look in that direction, I look in that direction, is the expansion rate the same versus distance in every particular direction?
Mm-hmm.
So, you know, that's why we have big surveys coming on, like the Vera Rubin Telescope LSST, because we typically have pencil beam surveys for the most part, or surveys that don't go too deep.
LSST was the Large Synoptic Survey Telescope.
Yeah.
But we're astronomers and we don't like going that way. We don't play that. So we just named it after one of our
You guys just like acronyms. You're just you're like the laziest group
Vera
of
Rubin
people.
telescope. Yeah, she discovered dark matter in the Milky Way.
Wow.
So yeah,
And speaking of, another telescope that's on coming is the Nancy Grace Roman
the
telescope.
Nancy Grace Roman telescope.
So
Let's look for dark matter or dark energy or both.
both of them. It's
Okay.
going to be a survey telescope. Yeah.
Everybody knows that, Neil.
Yeah. So Nancy Grace Roman, going back to the ASP, she valued the ASP so much that when she passed away recently, she left the organization a few $1 million.
Whoa.
Yeah. Yeah.
Okay, well, listen,
Whoa. Astronomers have millions of dollars.
Nancy Grace Roman had millions of dollars.
We're going to jump to the next.
Okay.
That was a great
Yes.
question,
Yeah.
James.
Yeah.
We're going to jump to the next one. Adam Omalan. Hi, Dr. Tyson and Dr. Olusi. Adam from Poland here. First, first of all, I am a big fan of everything Dr. Tyson is involved in. I love his books, all his programs he's been on. My question is about the ability to detect various particles in the atmospheres of very distant planets. We know that the light is altered as it travels towards us, but how exactly does this happen?
Ooh. Absorption spectrum.
Yeah.
Yeah. So it happens.
So what's
two ways.
absorbing what?
So what happens is that when you look at a transit of an exoplanet, so that means that it'll go in front of its star, right? And so at that time, the light from the star will pass through the atmosphere of the planet.
To the edges of the planet.
Yeah.
All right, so we're with you. You have this transit, and
Yeah.
the planet is moving across the surface of the. Now you don't see that.
You don't see it,
You just
no.
see light.
Yeah.
Okay.
Yeah, yeah.
So I'm getting light in my telescope.
So as that planet is going in front of a star, if it has an atmosphere, the light from the star passes through the planet's atmosphere, and that light
That's on the
interacts
edges.
with that atmosphere around the
On the
edges,
edges, uh-huh.
right? Yeah, that light interacts, and so certain wavelengths of light aren't going to make it out the other side; they're going to be absorbed, right? And that's going to
by
be
the chemistry of the atmosphere.
By the chemistry of the atmosphere, but remember. The star has its own spectrum as well. So you get a spectrum of the star by itself, you get a spectrum when the light is passing through the planet's atmosphere, and you subtract them. And what's left over is a spectrum of the planet. And now you can say, oh, I see this element or a molecule in that particular atmosphere.
And is that a constant? In other words, that is a proven theory that it works every time?
Well, it's hard to do. And so James Webb Space Telescope was built to do that job, and it actually has succeeded in doing that job. Those are some of the early releases, like, look, hey, we can do it.
It hasn't just succeeded. It's badass.
It's badass. Yeah.
It's opened up the whole industry.
Yeah.
To the whole
Yeah.
cottage industry to make that happen.
Yeah.
All right.
All right, we're going to go on to Jordan Vicina from North Dakota. I've been curious about dark matter.
So you went from
Denmark, Poland,
North Dakota. Okay, just
yeah.
clarify.
3 places I've never been to.
Okay. It may not ever go. All right. And I've been curious about dark matter. Is it possible that the reason why we don't understand dark matter is because it defies our understanding of the laws of physics? Meaning, is it possible that dark matter is something that can travel faster than light?
Ooh.
Or how massive gravitational effect without having large mass? Love the show.
Let me shape that another way and
Yeah.
throw it right in your lap. So we probe the universe using our methods and tools of science that we have developed to this day. Could dark matter simply be awaiting some brilliant theoretical understanding coupled with some brilliant new kind of telescope that would see it in ways that no one had previously dreamt? So is it awaiting technology? Is it awaiting new physics?
I think it's more basic than that.
Or is it going to plug in with just a new kind of particle that just doesn't interact?
Well, first off, trivia, my very first physics research
That's what I was wondering. You were in that.
was summer of '91 on the cold dark matter, CDMS, right? In the basement in Berkeley.
Okay.
Building the dark matter direct detection, right? Which we've not detected any dark
So your
matter yet.
PhD is from...
No. It's a funny thing. I got accepted. I applied to Berkeley and Stanford. I got rejected from Berkeley, accepted by Stanford. When
You
it
idiot.
did,
Got rejected by Berkeley.
Yeah,
right?
no,
I know,
exactly.
right? But here's
Send
the
him
thing.
off to Stanford.
I went and worked.
Where the idiots go.
Exactly, right?
Right.
Rejects. But no, here's what happened. I worked at Berkeley a summer between undergrad and grad on that project. At the end of the summer, they said, dude, if you want to come to Berkeley, come. But I didn't know Stanford was this highfalutin school. I didn't know that.
Wait, you didn't know that?
Dude, I was from the country, man.
Yeah,
We
but
didn't
you're a
have the
smart
internet.
guy.
His memoir is called From the Street.
All right, that's
to the
right.
stars.
All right, okay.
What
I
part of
got it
that
out the mud.
What part of that title do you not understand?
All right,
Red mud.
all right, you thought it was a town in Connecticut, not a university.
I didn't know Connecticut existed. So, and I still haven't seen it. But anyway.
And the town of Connecticut has an M, I think, doesn't
Yeah,
it?
it does, but
Stanford.
just go along with the
Here's
joke.
how I
will
like to
you?
think about this dark matter
Jesus, you're
and dark
killing me.
energy stuff, right? Nothing at the scale of galaxies and larger, or basically over 20,000 light years, bigger than the galactic arm, nothing moves consistent with the laws of physics. And so there's two ways, right? There's this like alternative gravity theories, which, just like when you think they're dead, they come back and they're stronger than ever. And then there's this, there's other stuff, dark matter. Oh, we got some great ideas for what that is. It's black holes, it's machos, it's
Dark energy,
supersymmetric particles. Oops.
Machos would be massive compact halo objects.
So we come up with our better
So
instruments and look
machos and
for
WIMPs
them.
are two kinds of...
Yes.
They don't exist. We look for them. They're not there. The supersymmetric particles, CERN should have saw them. They're
But
not
at what
there.
point, in all
The WIMPs, the
seriousness, do you go,
machos.
let's stop looking, and move on to something else? It's like looking
then
for
we'd have to say,
it's like
we're
looking
just
for
too-
a second sock, and you just don't find it.
No, because when we'd have to admit that we're stupid or that we're
Yes,
not.
exactly.
But we are driven by the uncertainty. There are ambulance-chasing theorists out there.
Yes, there are.
The slightest observation that's a little quirky, they're going to come up with a whole theory to
Oh,
understand
really?
it.
Yeah,
Oh, yeah.
maybe several.
Yeah.
Right? Because I only have to get it right once.
Is that what they call it?
I call them that.
So the answer is that sort of we're never going to stop trying to pursue this theory, and
Yeah, something is amiss. The
Yeah.
question is, what is it?
but is it
Right.
possible that dark matter is something that could travel faster than light? What is your theory on that?
Yeah. Well, we
If-
have
so if
those
dark matter-
tachyons. Is there tachyons? Is that what it is?
If dark matter is some kind of matter, 'cause we're calling it matter, but we don't know what it is.
Well, no, here's the thing why we know it's not that. Because there
Why
are
we
these
know it's
two
not?
models. It's not moving faster than light.
Mm-hmm.
Because the two models that we're competing were, is it hot dark matter or is it cold dark matter? So particles moving very fast would be hot dark matter.
Mm-hmm.
And we know that the best model is lambda CDM, cold dark matter.
Dark matter just feels, every time I read about it, it just feels like, I don't know, like a guy shows up at a party or something, and it's there, but it's
I
a
think it's
weird
in
vibe.
crisis.
It makes every.
The only thing
it's the
left
person
is
that makes
axions, and I don't find that to be well.
People making up particles that'll do this.
Yeah. Well, they made up a particle to cancel out the electric dipole moment of the proton, which should exist, right? If the quarks have electric charges and there's separation between the minus and the negative, there should be some what's called separation between them, which we call a dipole moment. But one is not measured. So Helen Quinn et al., they came up with this idea of maybe there's this other field that cancels it.
So it's the Wild West.
It's the
right
Wild
now.
West,
There it
man.
is. That's
Which
the
is
answer.
actually makes it exciting.
You come up with all these ideas and you go
It is
through all
still
of
the
them,
Wild
there's
West.
none of them.
All right.
But
Yeah.
because we know that whatever the dark matter is, it's cold and not warm.
Yeah.
It can't be going faster than light.
Exactly.
Because it would have evidence. It would
Yeah,
give
and it's
evidence of
clumping
that.
gravitationally, right? And then, you'd see, I imagine, shrink-off radiation, right? That's when you travel faster than
Right.
light in some medium.
Yeah.
You emit light. So dark matter wouldn't be dark, maybe.
Here we go. Next one. David from upstate New York. I recently watched a side channel show with Hakeem,
Word?
and I fell asleep. It was really boring. That was weird. Why would you write that, David?
I'm the guy who wakes everyone up.
No, you're the best, man. You're the best. I recently watched a side channel with Hakeem. It was about gravitational waves. Just wondering, can they also alter time? If a huge collision occurred near our solar system, how would we feel them? Would we be alive to physically notice?
So will it do damage, first of all?
Yeah.
And we know it's a disturbance in the gravitational field. And everybody knows after the movie Interstellar
Right.
that if you're in a different gravitational field, you're going
Right.
to age differently.
Yeah.
So
Yeah.
what kind of consequences?
That's a good question. Like the perturbations of time travel. This is a good time to bring up the Andromeda paradox.
Okay, that's what
that?
I was thinking the same thing.
I was not. What is the Andromeda paradox?
Well, the Andromeda paradox is the fact that if you and I are looking at Andromeda,
Andromeda, the galaxy.
the galaxy,
Not the stars that make the
M31 or
constellation.
whatever.
Right.
Yeah, not the constellation.
And not the
right.
strain that killed millions of people.
Not the Andromeda strain, right? 2.5 million light years away. Then what happens is, suppose you're sitting in your chair and I'm running by. And at the second I run by you, we both look up at Andromeda. Because I'm moving and you're stationary, we're going to see events that are days apart, even though we're in the same location looking at the same time.
can that
and
be?
you think that relativity. And you think that the
Don't just
light
say
arriving-
relativity and keep talking.
How
I know,
far?
right?
Wait, in this scenario, how far away from me are you when you're running by
You're in the
me?
same place.
We're in the same place, essentially.
So
I've
you're
never-
like literally
I've
running
never
here.
heard of this paradox.
And you look
right.
up,
It's a little known paradox.
and the
right?
thing
Yeah.
that you see and I see are days apart.
Days apart.
Because of our physical perspective on
Well,
that.
here's what you would think. You would think the light is arriving right now. We should all be receiving this light, but that's not how it works. Motion changes the perception of time. And so we know about that in terms of the local universe. We call it relativity of simultaneity, right? You're moving, I'm not. You see events as simultaneous. I see them as happening one before the other, right? But then when you add the distance component in it, now we see very different times. So there could be a third person moving in the other direction, seeing a different time. So how do you define what now is? So we
Even
don't
though
even
you're in the
understand
same
time.
place.
Even though you're in the same place, yeah.
While we're sitting here, I'm here, you're running by,
Yeah.
we look up at the drama at the same time,
Yep,
and we're
from the
seeing
same
something
location. From the same
days
location.
from the
Yep.
same location,
Yep.
essentially. We're seeing things days apart.
Days apart.
And
Yeah.
that leads to the idea of what is now, and your now and my now are two different
There's no
nows.
now.
There is no now.
No, there is
is
now. There's always now.
There's an
There has
illusion
to
of
be.
now because we're so close together and we're so small. The speed of light makes it feel like we have a now, right? But now doesn't really exist on larger scales. There's no such thing.
But there is always has to be a now in all seriousness.
No, that is your bias. That is your bias.
That's so Galilean
But that's
Newtonian.
That's
so backwards.
right.
Wow.
man.
I've
classicists.
I've never gotten heckled from the left and the right at the same
That's
time.
right. That's right.
All right, so wait, so what is the upshot of this?
Well, what was the question again? Because they're talking about time, right? And they're talking about now or something. And I'm just like, that now
What was it?
exists.
It was about gravitational waves, wondering can they also alter time? If a huge collision occurred near our solar system, how would we feel them? Would we be alive
Yeah.
to physically notice?
Right. You curve space and you stretch time, right? It's kind of the idea like what a black hole does, right? You curve space, time moves more slowly relatively. But these phenomena of gravitational waves are incredibly subtle. And so the real calculation to do is what type of gravitational wave would be necessary. It's like the
In
big
order
rip
for that to happen.
for that to happen.
To be felt.
To be felt, right? Or to be, you know.
Because the first one that was measured, it jiggled the experiment by 1/20th the diameter of a proton.
There you go.
You ain't feeling that.
You ain't feeling that.
But we know they were gravitational waves.
Well, yeah, we measure them, right? So, you want to think of what event, what magnitude of wave do you need, intensity, and then calculate what sort of event.
But there are
and
a whole-
that
give
event
rise
would
to that.
surely kill you before you had any
Right.
experience of the
I was
wave.
going to say, but there are a whole host of, it's an infinite number of things that could cause a gravitational wave, right? I mean, you
But
can-
actually, wait, the gravitational wave moves at the
A
speed of light.
feeling,
So it
yeah.
can't kill you before the wave hits you. That would all happen at the same time.
Oh, that's a good thing. You add those things.
oh, well,
right?
that's the upside.
No, you
There
don't
go.
even know.
You don't
Yeah,
even
you
know.
don't even
Yeah,
know.
yeah.
So you get compressed to nothingness, you get ripped apart. This is like a sci-fi thing, right? The gravitational waveinator. Exactly.
All right, we're going to move on.
Can we do a lightning round?
Yeah,
now? Or
absolutely.
you gonna,
we
like,
got
read-
some great ones. Here we go.
Okay, go.
Alan Geis, querying
Lightning
from
round, dude.
Portland,
You
Oregon.
know what that means?
Be even more loquacious.
Yes, exactly. right. Yeah, okay, here we go. I've always been bothered by physicists' preoccupation with conservation of information, especially in regard to particles falling into a black hole. Firstly, it sounds more like a philosophical position than one derived through mathematics or scientific method. Correct me. Secondly, Mr. Heisenberg taught us that one can never know all information about a particle. Thus, can't we consider that information to never have existed in the first place and thus can't be destroyed? I have one thing for Alan. Alan, if you're gonna ask a question on acid, you got to send the tablets to us too, so we can be on the same wavelength and answer
Wait
the
a minute,
question.
Tablets?
Go.
You mean tabs?
Tabs. There you
They
go.
ain't a tablet.
There we go.
See,
There we go.
He's not it.
There we go.
He's,
Alan Geis, go
What
ahead,
kind of-
answer that
he
question.
actually remembers the 60s.
Yeah,
That's the
exactly.
problem. If you lived through the 60s, you shouldn't remember.
There you
that.
go.
All right.
Yeah.
So I like
say,
that. So
I
catch us-
say here. I say here. I
Catch
felt
us
the
up
same
on
way.
the information.
This is a cultural phenomenon. Nerds ain't cool, and so they try to make something cool that ain't cool. All right, so this whole thing about do black holes have hair? We made a bet, man. Nerds, shut the hell up. Nobody care.
Damn.
I don't care. So here's what I think they're saying. Right, if I look at the sun, I can take a spectrum of the sun.
Just to clarify, he said black holes have no hair.
Yes,
What
yeah.
he meant was that when matter becomes a black hole, it should have only like three
Yeah.
physical parameters, like angular momentum, mass, charge.
Yeah,
in charge.
yeah, yeah.
So the idea was whatever it looked like before, it has none of that later once it becomes a black hole. So it says it has no hair. But that's back when enough people had hair that was an important part of how you identify them.
Right, exactly.
But now that bald look,
Right.
the
Which
Lex
is the whole
Luthor,
thing.
the
Wait,
billionaire
speaking
with
of
the
which-
bald look.
Yeah, exactly.
Hey, speaking of which, you know something I realized?
What?
So, I grew up in segregated Mississippi. So I go to graduate school and I would play basketball all the time. And I noticed
That you sucked at it.
oh man, I didn't suck until I joined the Cambridge Athletic Club League at the age of 49. Then I sucked.
Okay.
In the 90s, I was great. But here's the thing. I noticed something. And that is, if there was a white dude who wasn't present and you're trying to describe him to someone, they invoke his hair color.
Yes.
We didn't do that. That
Yeah,
was
it's not our vocabulary.
I don't know. We
It's
would
like in
invoke
China.
the
Wait, you
skin
mean
color.
they'd say like, Paul McCure, the guy with the dark hair?
Yeah, exactly. Yeah.
Right.
No,
Never-
it's like in China. You don't imagine people are IDing each
No,
other.
'cause when I talk about-
invoking hair color,
Like when
Right,
I-
exactly.
It's the person
when I
with
go
the
like-
black straight hair. That's not helpful.
But where I'm from, we invoke skin color. Oh, the light skinned dude, the red bone, the yellow bone.
See, I do it with
I'm-
voice. Like,
yeah.
Neil Tyson, he talks like James Earl Jones. I do it like that. You do basically.
This is CNN.
So we're going to move on.
So
all right?
no, but the point is that some nerd thing that nobody. But let me tell you what. Unlike a black hole, take the sun. Right, you can reconstruct what made the sun. That's how we know. Oh, the sun looks like 3 dozen supernovae constituted. You can look at what it's made of today and reconstruct where it must have come from. You can't do that with a black hole. Right? That's the. I think
So
that's
you're
what they're
in
getting
the we lost information camp in the black hole.
Clearly.
Or information, there's too much made of this information idea.
Both. Exactly.
Okay, this
Both.
is where he's coming from.
Yeah,
Okay.
yeah, yeah.
Give me another one.
There we go. My name is Ross. I live in Madison, Wisconsin. Could dark energy, whatever it is, be the mechanism behind the big squeeze? As an analogy, consider a magnetic field. It comes out of one pole, folds back on itself, goes into the other pole. Imagine this magnetic field being the fabric of space-time
Is that
propelled
about
by
dark energy? No, the point is the dark energy is making us expand and never return. So
Yeah.
maybe he meant dark matter.
Okay.
So is there sufficient dark matter to close us back and then have the big squeeze?
No, not even close.
Not even close. Okay. So
Lightning
give up on
answer.
that one.
Lightning answer.
Yeah.
Right. Okay, next.
Okay. When were we, this is Christopher from St. Louis, when were we looking into the cosmos for possible Dyson spheres? What criteria are we using to tell the difference between a Dyson sphere and something else?
Let me get that Dyson sphere out of your mind right now.
All right.
All right, because I did a little calculation. Right. And
So did I. Go ahead.
okay.
Oh, by the way, just make it clear, there are people who, when they want to know stuff, they look it up on the internet. But when you're a scientist, you calculate the answer. Okay?
Right.
I gave someone an answer one time. Oh, what source did you use?
in my education.
It's called the Brain app. You should try it. Okay, try it sometime.
It's called
Okay.
book learning.
So basically, you're not going to have enough matter to build a Dyson sphere. If you took all of Jupiter and you try to make a Dyson sphere around the sun using all of it, the idea is that matter, that's like taking a human eyeball and trying to make a sphere around a basketball using that
So
material.
you're trying to harness the energy of a star
You're trying
using
to
this artificial.
You're trying to absorb it in matter, right? And then convert it to useful energy, right?
Right.
And so you do not have enough matter in the solar system
to create something
to create
larger.
something that you could put around
Because
the sun
it's not
to do that.
large enough, or because it can't hold.
Because it's not large. It's not. It's like
The stars are so much bigger than their planets.
Have you seen the
Exactly.
garbage bags that Costco sells? You put one of those around a star. Come on,
Totally
guys.
get it. No, so
they're hot.
So let me add to what you just said, because that's a brilliant revelation regarding the material necessary.
Right.
If you had that much material, it means you're visiting other star systems.
Why would you be wasting
you
it?
can't- This is not even an interesting
Why?
exercise.
You don't even need it at that
It's
point.
like, what are you trying?
Yeah. You know,
You're
we need
scooping
more.
up the planets of 1,000 solar systems to get the energy
Right.
from one star.
Create that-
What the hell are you doing?
Hey guys, we already got the
It makes
energy.
no
Why are we
sense.
trying to create the
Yeah.
energy?
You know what? The
And
sun
by the-
already has a Dyson sphere. You know what it's called? So when you think of the sun, you think or a star, you think of it as two parts: the core and the envelope.
Right.
The envelope is a damn Dyson sphere.
It's already there. It's just
glowing.
naturally.
It's
naturally-
glowing.
50% of the matter, right? 50% of the matter is in the core, 50% is in the envelope, and it's absorbing the energy that's coming out and radiating into a useful form that we can build our solar arrays and capture.
Let me add to that. Last year, there was a research paper on a observing project to look for Dyson spheres.
Wow.
Now, you know how they're going to do this? They're looking for very, very red star systems.
Oh, so they're not getting all the energy.
Well, they're
stepping it
just
down.
saying that if you absorb all the energy from a star at this greater radius,
Yeah.
then it would then radiate
Yeah. In the infrared.
in the infrared.
Yeah,
And so
yeah.
they're suggesting that they're aliens. So they have a data set of a
They're
handful
cheating
of...
because there's all these stars that are enshrouded in dust that do the exact
That's
same thing.
exactly the rebuttal to that.
Yeah.
That there's stars, when you're in dust, it absorbs the energy and it re-rates it and radiates it. It makes the star look very red.
Yeah.
So that was the ordinary explanation for those very red stars in that experiment. Anyhow, we got to wrap.
Yeah. Okay, can I say one more thing?
No. Okay.
Astrosociety.org.
Oh, Astrosociety.
Astrosociety.org. Come join us.
Yeah, the Society of the Pacific, yes.
And it may very well soon be the Astronomical Society.
You could be a nerd, you could be a geek, you could be an enthusiast.
You could be an educator, you could be a learner, all of that.
Yeah.
Yeah. And you can give more than you want, but we have a very low donation. We ask to become a member of our community.
Here
like
we
$20.
go. It's about money.
No, it's not, man. But you can give more.
Okay, so here you go. Under your leadership, will it become the Astronomical Society of the Planet?
I think so.
Okay.
And the other thing is, let me tell you my other
As
thing.
it should have been.
My big thing is going to be, I'm going to take humanity, and when I look at the history of mathematics, so here's the thing, right? The big bottleneck for people getting into STEM is math, right? When people go to college, they ask themselves 3 questions when they choose their major. What do I like?
How much math is it?
How much money can I make doing it? And what has the least amount of math?
Exactly.
Right? And so what needs to happen is, so when I look at I look at it historically, and I look at it in 4 phases. There's an early phase, let's forget that. Here's how I name them. The Library of Alexandria, that's when you have, Euclid, you got the Pythagorean theorem, all that exists. You got basic geometry. Then you go to Nalanda, or the City of Learning. This is Aryabhata, Brahmagupta, the Gupta dynasty, right? Where they come up with the place value system, the numerals that become Arabic numerals, zero.
Because they're really Hindu numerals. That's
they're
how they
really
started.
Hindu numerals,
right?
right?
And the zero comes out of there
exactly, right? And then the third step is the House of Wisdom, right? This is where you get quadrasmy, solving equations, the stuff we do in STEM every day. And then you go to Cambridge, all right? So right now, Newton. Right now,
Cambridge, England.
The average human on Earth, if you stop them and ask them any math question, they got the first 2 steps covered. We need to raise humanity,
which
to
is
the House of Wisdom.
arithmetic and a little bit of algebra.
Exactly.
Trigonometry. Maybe,
but if here's what I mean. If you go up to the average person, you say, "Hey, what's 2 dogs plus 3 dogs?" They'll say 5 dogs. What's 2 galaxies plus 3 galaxies? 5 galaxies. What's 2x squared y cubed z plus 3x squared y cubed z? Get out of my face, nerd. It's the same problem, but they don't realize it because we haven't learned
I don't say
House
get
of
out of my
Wisdom.
face. I whip out my Texas Instrument, bang, bang, bang.
Texas Instrument. Holy cow.
There you go.
Yeah,
That's
he keeps it
old
right
school.
next to his Palm Pilot.
There you go.
So anyway, I want to raise the level of humanity.
I have an HP.
Join us.
HP 45 in there.
I got a Clepsydra and a star. What is that thing? Sundial.
There you go.
Wait, I got a stone circle.
Nice. A Stonehenge. You got a Stonehenge in your backyard.
I got a Naptoplaya.
All right, we out. We out here.
Yeah, peace.
Yeah. Hakeem, really
Yes,
good
sir.
to see you again. Thanks.
Man.
Your first time in my office here
First time
at the
office,
Hayden Planetarium.
First time I've touched you in 20 years.
That sounds a little creepy.
You're welcome. You're welcome.
Boy.
So this has been Star Talk, Cosmic Queries Edition, Potpourri, with my old-timey friend and colleague, Hakeem. Welcome back. And,
Thank you.
of course, Paul.
Great to be here.
All right. Till next time, I bid you to keep looking up.